multiple integrals. I'm just giving you the assignment corresponding to the multiple integrals. So I would like to give you a brief instructions regarding to the problems that I have already given in the assignment number 3. Overall it consisting of totally 11 problems. So in that I'm just giving you one by one so that you can practice it and you can have an idea on how to do the problems on the multiple integrals. If I am going to take the first one, evaluate double integral 0 to 5, 0 to x square, x into x square plus y square of dx dy. This is your problem. So whenever such type of problem is given, the thing is you just look on to the limits of the integrals. One integral consisting of real numbers 0 to 5, another integral 0 to x square. So second integral involving the variable x. So automatically you can say that these limits are corresponding to the variable y. So first integral x integral, second integral is y integral. So first you eliminate the variables first. So do the integration with respect to y and find out the simplification, substitute the upper limit minus lower limit, then you can do the integration with respect to x, then you can find out the answer. So final answer as per my calculations is 29 into 5 power 6 divided by 24. So this is about your first problem. Okay. Now coming to the second one, find double integral 0 to 1, 0 to x square e power y by x dy dx. They have given the same procedure. One integral involving real numbers, second integral involving x variable. So automatically second integral is nothing but your y integral and the first one is x integral, and just you do the integration first with respect to y, substituting the limits, then you are integrating with respect to x and substitute the limits. A very simple. Remember, whenever you are doing integration with respect to y first, e power y by x, which is nothing but same e power y by x divided by y coefficient is 1 by x. Then you can substitute the limits. So finally, on making the simplification, the final answer is 1 by 2. Okay. Now coming to your third problem, evaluate double integral xy dx dy over x square plus y square equal to a square. So this is about your third problem. And in order to evaluate the double integral, you need to have two integral limits. But here limits are not given, only an equation is given, x square plus y square equal to a square. As I told you, in order to find out that one, the first thing is focusing on the second variable y. So from that you calculate y square equal to a square minus x square. From that you can calculate the y limits, and y limits 0 to that particular under root of a square minus x square. And coming to x limits, substitute y equal to 0 so that you are getting x limits are 0 to a. So just you do the simplification. First y integration, then x integration, substitute the limits, and you are getting the answer is a power 4 divided by 8. This is about your third problem. Now coming to fourth problem, evaluate double integral y dx dy over y equal to x square and x plus y equal to 2 in the first quadrant. So in order to get that particular value, again the same procedure. Double integral means you need to have compulsory two limits, that is variable limits, x limits and y limits. The one thing is two equations are given. So from those two equations, first you calculate y. So one is y equal to x square and another is y equal to 2 minus x. Then you solve these two equations so that you will get x values first. By using the procedure on solving these two equations, you will get x values 0 and 1. So x limits 0 to 1 and y limits are x square to 2 minus x. First you do the integration with respect to y, then with respect to x, and just substitute the limits. You will get the answer is 16 by 15. Only you just make the simplification that gives you your answer. Now coming to your fifth problem. Giving that find double integral 0 to 2 and 0 to under root of 2x minus x square of x square plus y square dy dx by changing into polar coordinates. So whenever you are using the technique of changing into polar coordinates, as I told you in the procedure, you are changing first variables x and y into r and theta. So from that you can directly find out x equal to r cos theta and y equal to r sin theta. After getting that, it has to satisfy a condition x square plus y square it is equal to r square. So by using that, after getting that, now we need to find out dx dy value, which is nothing but r into dr d theta. And the thing is, we need to focusing on limits of r and theta. Very simple. Lower limits in both the variables 0. You substitute both the lower limits in x equal to r cos theta and y equal to r sin theta, so that you can find out that theta limits 0 to pi by 2. The next is, in order to get r limits, the thing is, you use the equation x square plus y square equal to r square. From that, if I am going to substitute both lower limits first, you will get 0, and one lower limit and one upper limit in different combinations. You are going to get one more r value is nothing but 2 cos theta in your given equation. So it is root of 2x minus x square. From that you are getting r limits are 0 to 2 cos theta. So just you do the simplification. First you do the integration with respect to theta, then substitute the limits. Just on making the simplification, here you are getting the finally it is cos power 4 theta. So in order to get cos power 4 theta, that I can write cos square theta whole square. That cos square theta can be taken as 1 plus cos 2 theta. It is whole square is there, a plus b whole square. Just you do the simplification and substitute the limits. You will get the answer is 3 pi by 2. Now you look at the sixth problem. The sixth problem is find double integral x square y square by x square plus y square of dx dy between x square plus y square equal to a square and x square plus y square equal to b square, where b is greater than a. So in order to find out that particular sixth one answer, only the thing is nothing but you are using it is the change of variables into polar coordinates here. So very simple. First you are starting with x equal to r cos theta and y equal to r sin theta, so that dx dy equal to r dr d theta. And in order to get the limits here, remember that the equations are given x square plus y square equal to a square, x square plus y square equal to b square. If it is compared with x square plus y square equal to r square, there r is taking the values a and b. So lower limit to upper limit, given that b greater than a means r limits are nothing but a to b. R limits a to b. Now in order to get your theta limits, since both the equations are representing circles, the circle angle is nothing but 0 to 2 pi. So by using that particular answer, r limits 0 to that a to b and theta limits are 0 to 2 pi, and just you substitute the values there, you will get final simplification pi by 16 into b power 4 minus a power 4. Only the thing is just a simplification. Now you look at your seventh problem. Find double integral 0 to a and another integral x square by a to 2a minus x xy square dy dx by changing the order of the integration. So order of the integration, that is one important topic here. In order to change the order of the integration, first you focusing on the limits of the integration. First is real numbers, second integral consisting of x variable. So second integral is y limits and first integral is x limits. So here already dy dx is given, you are changing the order is dx dy. So in order to change that one, you just look onto the limits 0 to a and x square by a to 2a minus x. By using that x value 0 to a. So x is 0 means it is totally on y axis. X equal to a means somewhere at x axis a point you just locate it. And for the next equations, y equal to x square by a. From that, x square equal to ay. It is nothing but a parabola equation. X square equal to ay means that is nothing but a parabola symmetric about y axis. So just you draw one parabola symmetric about y axis. Similarly, when you go for the next one, y equal to 2a minus x. From that you can write x plus y equal to 2a. So using that x plus y equal to 2a, you are just substituting the different points there. If I write x equal to 0, you will get y equal to 2a, and x equal to a, y equal to a, x equal to 2a, y equal to 0. Like that you are taking only the 3 points, so that you are going to get, on locating the points on the graph, you are going to get one straight line that touching that your already drawn parabola curve. So from that you just identify the common area. So after getting the common area, so what is the order now? It is dx dy. So in order to get that value, x limits now it is in terms of y variable. So in that case, now you are going to construct one strip. So what about the strip now? Are you going to get the strip is the strip that x limit in terms of y means, so you are going to get one strip, it is horizontal to x axis, parallel to x axis. So from that you just denote the strip p and q, and at the p point you write down the x value, at the q point write down the x value, and that strip is moving in the common area. You just identify that one, so that you can get y limits are 0 to a, and y limits are 0 to 2a, and x limits are nothing but it is 0 to 2a minus 1. Is it right? So it is one is x limits are 0 to a, and y limits are 0 to, it is root ay, I think. You just, and here one problem is there here. When you are drawing this particular thing is, when the strip is moving in the common area, it is basically divided into two different parts, lower part and upper part. You just look onto the problem, lower part and upper part. In both the cases you need to calculate x limits and y limits. So in the lower part you draw one horizontal strip, even upper part also you draw one horizontal strip, and find out the x limits. So in the lower part you are getting x limits 0 to a, and y limits are x limits are 0 to root ay, and y limits are nothing but 0 to a. Similarly in the next part, x limits are 0 to 2a minus y, and y limits are 0 to 2a. So just you are taking the integrations on these two parts, and just you do the simplification, you will get the final answer is 47 into a power 5 divided by 120. So only the thing is, while taking your strip, you need to identify whether the strip is moving, are you going to change any p and q values? That is the important. If no change is there, then only one strip. If change is happening, better you divide the common area into two different parts. In both the parts you are calculating x limits and y limits and find out here. Here you are getting two parts, that's why you are getting combination of two integrals. So final answer is calculated. Now you look onto your eighth problem. It is use the change of order of integration to find double integral 0 to 1 and integral x to root of 2 minus x square x dy dx divided by under root of x square plus y square. Again, in order to change the order of the integration, the same procedure. So first you identify the first integral is x integral 0 to 1, second integral is y integral x to root of 2 minus x square. So this dy dx, now you are changing into dx dy. So in order to get new limits here, you take the values x equal to 0, y x equal to 1, y equal to x, and y equal to root of 2 minus x square. Now you construct a diagram here. X equal to 0, as usual it is lying on the y axis, x equal to 1. somewhere on the x-axis you are locating a point, and y equal to x is nothing but it is a straight line passing through the origin directly. You draw one line passing through the origin, and one more is y equal to under root of 2 minus x square, or squaring on both the sides, y square equal to 2 minus x square, which is nothing but x square plus y square equal to 2. So which is nothing but a circle equation. So circle equation and having its radius is nothing but 2. So just you 2 means it is totally on all the sides it has to be 2. So just you construct one circle around your total plane. But here, since x is taking the values only 0 to 1, so you are focusing only on the first quadrant of the plane. So draw the circle only in the first quadrant, then you identify the common area. Here the problem is again, when you are doing the common area, and there you are getting again the common area is divided into two different parts here, lower part and upper part. So there again you are calculating a strip in the lower part and as well as your upper part. So by that you are going to get two different limits for x and y variables. So if I take one part, the x limits are 0 to y and y limits are 0 to 1. Similarly, in another part, x limits 0 to under root of 2 minus y square and y limits are 1 to root 2. So there you are going to get two different limits, and just you do the simplification, substitute the limits, combination of two integrals, you can get the final answer is 1 minus 1 divided by root 2. Now look at your ninth problem. Find the area between y equal to 4x minus x square and y equal to x. So in order to calculate the area, I am using double integration. So two equations are given. So you solve those two equations so that you can get your x values 0 and 3. Okay. Then directly the y values are already given. It is nothing but 4x minus x square and y equal to x is given. So what is the minimum value there? You just substitute one of the values. Suppose if I write x equal to 1. So where you are getting minimum? Minimum is y equal to x only. So that lower limit y equal to x to 4x minus x square. So just you do the double integration and formula. You know that area, it is the double integration just dy dx. So directly do the integration and substitute the limits. You are getting the answer is nothing but 9 by 2. Now you look on to your 10th problem. Find the value by double integral for x square plus y square equal to a square and x square plus z square equal to a square. So since they are asking volume by the double integral, you know that the procedure is, it is very simple. Double integral z into some dx dy. That is the formula to calculate your volume by the double integration. But before going to that, you just find out the limits first. So in order to get the limits, so from the second equation, you will get z limits. And since you are considering only that two variables xy plane, so you suppose that it is y square equal to a square minus x square, so that only y equal to under root of a square minus x square. And if I am going to consider x limits y equal to 0 means you will get x limits are only 0 to a. Remember, while doing this problem, you need to think about only you are taking the positive values. Don't consider the negative. Reason is, if I take x square equal to a square, then x equal to plus or minus a. In that case, you will get a different answer. Only you make a statement that you are considering only the positive quadrant. By that you will get x limits 0 to a and y limits are 0 to under root of a square minus x square. That gives you the final answer is a cube by 3. So that is about your clue.